If you are building AI agents, chances are that the way you are testing them is missing the mark. It's not your fault as well. There is no set playbook for this yet. Even the biggest labs don't agree on how do you test the AI agents. So now here's the problem. Most teams find out about it too late. So your AI agent passes every test you wrote, then it gets shipped, and in production it says something that nobody scripted it for. Conversational bots don't break like traditional software, but most teams today are still testing them like the way they do a traditional software testing. And that gap exists because the AI agents are non-deterministic, same input, different output every time. Conversations branch, contexts compound. Now, the traditional testing was built for code that does the same thing every time, each time. Agents don't. How do teams test conversational agents today? Now, as I said before, there is no fixed playbook. If you ask from different companies, they will have different ways to test it. For example, for OpenAI, it recommends eval-driven development and human calibration. For Google, it centers on adaptive and static rubrics plus deterministic metrics. Microsoft structures it around pre-production evaluation and post-production monitoring. Anthropic, on the other hand, works around single-turn, multi-turn, and biased evals with automated and human grading. NIST, the governmental body, adds pre-deployment testing, field testing, and ongoing monitoring in its recommendations. Now, one thing they all agree on, though, that it's a layered approach. It is not one workflow. There is no single benchmark. You have to do all. So now let's condense it down to the three most common approaches, kind of a categorization, broad categorization. Each one works, each one breaks. The first one is manual review. A human expert talks to the bot or they read the production logs and flags what went wrong, what went right. It catches nuances that a graded metric may miss. But it cannot be scaled up. It's slow, it's subjective, inconsistent. So two reviewers can grade the same chat completely differently. In fact, the same reviewer can grade it differently on a tired afternoon. I didn't have my coffee today. Now, a human can cover a few conversations, maybe a few dozen scenarios in a day, but not a few thousands. As we talked about earlier, the agentic conversations branch into exponentials. It's not one or two things that we are testing, it's thousands. Now, second is an LLM response or an LLM eval, sometimes also called an agent eval. You would have been hearing about this term a lot, eval. What it is, you take one input in, one response, and check it against a fixed answer. And this grading can be done by the LLM itself, an LLM-as-a-judge. It's a very important term. It's fast. It can be dropped straight into the CI/CD pipelines and give precise answers on where the agents gets wrong. And this can also be retroactively done for all the past LLM API calls that you can check in bulk across all singleton inputs and output outs. It can be done at scale, so you can grade at scale, and you can figure out very precisely where things are breaking. But the drawback is that it tests a single turn in isolation. Real conversations aren't single turn. They are not just an input in, output out. They can be of 20 turns, where each reply depends on everything before it. And practically, state drifts, error compounds, and a single eval cannot predict any failure that only shows up after, let's say, turn 14. Now, there is also a scoring problem. We talked about LLM as a judge. Now, LLM as a judge can grade thousands of conversations. Of course, it scales, but LLM also comes with their own bias, and it depends heavily on the guardrails or the rubrics that you give to it. It's not 100% perfect. So we come to the third approach. How do you do it? You create synthetic user simulations. Now, this is where things get interesting. You pair your agent with a second agent The second AI agent plays as a user. It holds a persona, it drives a full conversation, pushes your agent across hundreds of turns if required. Now you are testing the agent the way it is actually used, full dialogue, real estate, at machine scale. But there's also a problem. Simulations can also be a trap of its own. You cannot use the same model as a judge. Why? Because it can fall into the same recursive confirmation bias, a bias that goes across the whole LLM that you are using to build it. So bias agent with the same blind spot, agreeing with each other across every turn and all the way to clean transcripts that proves absolutely nothing. And most importantly, tokens costs start to climb up. One well-behaved simulated user never reproduces human chaos. The impatient one. What happens if a user comes in that trusts nothing? What happens if the user starts to type in 3 different languages and changes their mind mid-sentence? Are you able to simulate all of that? Now, what about real traffic latency? What about if there is a tool call that can happen in between fails? What happens if somebody tries a prompt injection? What happens if there is a load? Now, around 5% of all API calls fails in production. That's not because there is a issue with the AI. That's because they also hit capacity limits. So your pre-release data sets can never see that kind of scale. Now, here's the consistent method that it points to. The single approach, no single approach is enough. You need all approaches. And there are so many tools in the market for things like keyword, but one area where there is a biggest gap right now is how to do simulated end-to-end conversations. We have established you need AI agents to test AI agents. There is no way around that. And this is where agent testing by TestMu AI does its best. We spin up a swarm, a fleet of adversarial AI agents that surfaces exactly how your agents actually behave in full. They are adaptive, they perform multi-turn conversations and actively challenges the other side across multiple different scenarios. And most importantly, we do it right. It's not just one polite simulated user, it's a library of adversarial personas, an impatient corner, a confused novice, a security prober. It tests across different channels, chat, voice, phone, with real accents, real background noises. They are specialized testing agents that we built based on our experience of multiple organizations. They are running in parallel security researcher agents, bias detection agents, hallucination agents, agents that detect whether your AI agents are performing as it's supposed to perform. And most importantly, this is judged based on a calibrated human in the loop feedback. You cannot have to test blindly. There is a human in the loop that can course correct. The math is simple. While a human can do dozens of test conversations in a day, an agent can run 10,000 or a fleet of agents can run 10,000. And we have a real life case study. We had an e-commerce customer whose team scaled from 200 manual scenarios to over 10,000 automated ones. And they were able to push their agents' customer satisfaction score from 38% to 84%. With the right personas and the right metrics, our agents can find the failure on turn 14 before your customer does. So it's a no-brainer. To catch or test an AI agent, you need an AI agent. And TestMu AI's agent testing platform is the only one that can do it right. So if you are building AI agents, we can help. Let's talk.